You must come now. I don't want to, so let's wait a little bit. Patience, that's all we need. Patience, that's all we have. Yeah. What happened? I don't like that sound. You don't like it. Well, my dear Ruth, I know you're here. Thank you for coming. You're the first one. Let's expect a little bit, please. I know you cannot talk at this moment, but don't worry, I understand.
Yes, I will try to participate a little bit.
Thank you so much. So if you cannot do it, don't worry, I understand the situation. Fabiola and Johan, welcome. Thanks for being at this moment.
Good evening.
Hey, teacher.
Let's wait a little bit more, please, because we are just 3 students. And well, tonight we have some connection disturbances. So I'm trying to correct it, okay? Hi, Belkinagar, welcome.
Hi, good night.
Hi, my dear. Well, let's have a little patience. Back again. Okay. Let's start checking the systems. Hi, John Harold, welcome. I think we are enough.
Hello, teacher.
Hello. Well, I think we are enough at this moment, so let's start. Let me open the slides. Well, today we have a class, as I was telling you, when we are going to check lots of new vocabulary and, of course, statistics. Well, we have lots of pictures here. It's a little bit longer than I expected, but it's important for us to review this and check the expressions, okay? So can you watch my screen? A green one.
Yes.
Yeah.
Okay, thank you so much. So let's go ahead, okay? If there is any connection disturbances, maybe, or any problem that you cannot get into participation, reading something, please send me a message by WhatsApp and I'm going to take it in count, because today the Wi-Fi, the internet connection is not very good, okay? In that way, let's go ahead. Today we are going to talk about research studies, and presentations, data presentations. It doesn't look as if it's very much data to check up, but it's a lot of information. And of course, I'm checking the most important parts, okay? The most important expressions, way of reading, and I consider that that's the correct point we need, no more than this part. And in order I was telling you yesterday, this presentation, of course, is going to go to the final test. So if there's any question, you can write it down, and tomorrow during the workshop, we can work about it, okay? In order to finish exactly in an hour. First of all, we have the definition of research. It's not the same, the common research and the medical research. About research just, we know that this is the systematic investigation into and a study of materials and sources in order to establish facts and reach new conclusions. So we get this general idea. We study something that is unknown for us, and then we get new conclusions and get more knowledge. That's all. Talking about research in medicine and health disciplines, we must understand that this kind of research is directed to get more resources for solving health problems, of course. It is conducted using scientific methods with the aim of acquire new knowledge about health and disease. That's the important topic, scientific methods. It's not just go to look for something extra. No, of course, we don't have to think in that way. A scientific method, of course, we know all of the steps we follow for getting into a conclusion. And of course, we can repeat the process. And again, we can check the same result. That's the idea. And research in medicine, of course, follows the scientific methods, okay? We have here the pronunciation of these specific expressions: research studies, research study, a scientific study of nature that sometimes includes processes involved in the health and disease. Not always it's possible to be involved in this process of health and disease, but it's important to get the idea, okay? For example, clinical trials are research studies that involve people. These studies may be related to new ways to screen, prevent, diagnose, and treat disease. So in that way, in that order, we have the idea, the correct definition of this kind of research, okay? And these studies, of course, are specific. For example, we have the case control studies, okay? John Harold, can you read this slide, please?
Yes, teacher. A study that compares two groups of people, those with the disease or condition under study cases, and a very similar group of people who do not have the disease or condition, controls.
Thank you so much. So we have to get the difference of this, okay? The case control, John Harold was reading, is the comparison between two groups, two ways of viewing, one with the disease and the other one without the disease, of course. And then we compare the differences and the process through the time. Here we have this extract from a group, from an article, and it says some ways to understand the case control, how the case control study is working. Johan, can you read this, please?
Of course.
Thank you.
In a case control study, a group of people suffering from a disease, the cases, is compared with a group who do not have the disease, the disease, but are similar in other ways, the controls. The two groups, the participants in the study, are compared to see if they were exposed to a possible risk factor or not. A risk factor is something which may contribute to the cause of disease. This type of study is often used as a first step in identifying the cause of the disease.
Thank you so much. So that's why we were talking in the last slide and this one. The case control just compares. We have a similar general group, a population, and this population has many similar data. For example, females from La Paz. And then we choose a disease. And then we try to organize our variables looking for the disease and organize the data, dividing into groups, the ones with the disease, for example, breast cancer. And we look for the risk factors that are in common with the population is with the disease and the population that is without the disease. And we try to get the difference, why the group with the disease goes with that disease and why the other group not. That's all. We have this picture showing us the general idea about this situation. It's a little confusing because it takes the cases that are divided, and then the controls and the results, okay? And for example, with the lung picking about, and then from this disease, we can look for the risk factors, in this case, smoking. So in that way, we can choose our population, general population, and our group of control, and then we can go ahead. Now we have another kind of study, the cohort studies. Catherine, can you read this slide, please?
Yes, teacher.
Thank you.
Cohort study are a research study that compared a particular outcome, such as lung cancer, in group of individuals who are alike.
Yeah, alike.
In many ways, but differ by a certain characteristic.
Yes.
For example, female nurses who smoke compared with those who do not smoke.
Thank you so much. So we can see our populations in this example, the female nurses. And then we divide into the two groups, the ones that smoke and the ones that don't smoke. Now we get the conclusions why they get with cancer. Sometimes there is no possibility. Then we have again this extract, this picture from an article. That it's simple, okay? In a cohort study, a group, the cohort of people, the subjects, who are similar is studied over a period of years, a longitudinal study, of course, through the time, through a few years, like a line, we make this study. That's why it's called longitudinal study. We determine if there is a relationship between exposure to a risk factor and development of a disease. At the beginning of a prospective study, none of the subjects had the disease. They are followed up for a number of years, and at the end of the period, those who have developed the disease are compared with those who have not. Okay, so in the prospective study, of course, we check through the time how these people, this group of control, this control group is getting sick, is getting with the disease, and then we can take the correct conduct, and then we can study the risk factors with more detail getting the conclusion how these risk factors can get us into this kind of disease. The prospective time starts with people that is without any situation. It's sane people by the end of the study, because it could be by 20 years, 4 years, 50 years, it depends on the study. Then we can get the conclusion why the disease population in the study got the disease. So we can study the risk factors specifically. In a retrospective study, the researchers look back by studying hospital records, for example, and at what has happened in the past, comparing subjects who have developed the disease with those who have not. So in that way, in the retrospective one, we got the idea. Then we go back in years and then check clinical histories, clinical reports, and then we can get the conclusions why people got, for example, with prostate cancer in a group control with men from 40 to 60 years. And according to the medical reports, medical history, we can check and we can collect all the information and then get the correct way of this development, okay? In this case of the prostate cancer. In a cohort study and in a case control study, the subjects are only observed and there is no intervention. We don't have to do anything, just check, compare data, compare numbers, collect all the information and get into conclusion. In conclusion, I mean, we don't have to use drugs, treatment, or surgery for trying to solve the situation. Just get the conclusion, and from we get the conclusion, we can take another time, another way of control, another way of treatment, I don't know. A cohort study is more reliable method of identifying the cause of disease than a case control study. But for proof of cause, a trial is needed. Trials are the most common ways of we are learning and practicing, and we are exposing our population into this kind of situations, okay? So it's interesting this way. So I have the similar chart we were checking. We have the risk factors, the exposition, and during the cohort study, we check how these situations get to the lung cancer. We study how these ones get into the consequences. That's all. Now we have the trials. Belkin, can you read this slide, please?
Yes. Trials. A type of research study that tests how well new medical approach works in people. These studies test new methods of screening, prevention, diagnosis, or treatment of a disease.
Thank you so much. So we were checking the screening processes last presentation, and we have the idea, the general idea about this. Now we have the studies, the trials specifically, that are important for screening, prevention, diagnosis, treatment, in order to get solutions, to find solutions, to find new drugs, maybe to find new procedures, to find new combinations. That's why we consider trials a very important part in our medical practice in the daily way. So we have again this extract. Don't forget, we have this friend that is showing us that it's an important picture because we have more vocabulary in Black and words, and it's important for us to remember about it and practice. So let's go. In a trial, a group of people who are suffering from a disease are given a particular treatment. We know it. To determine the effectiveness of the treatment, a controlled trial is performed. We divide the population we are studying in 1, 2, or 3 groups. That's okay. One of them receives the treatment and the rest does not. Easy to get until that point. Usually we divide it into 2 groups. they are studied, and one group, the study group, is given the treatment, and the other, the control group, did not receive the treatment specifically. That was, for example, I was telling you in the last class about that no-beneficence study when we were talking about the penicillin and the syphilis, right? The group was receiving penicillin and the other group was not receiving penicillin, just water in shots, okay? The controls may be given a placebo, the water in this case, something which seems to be identical to the treatment, but which has no effect. There is an equal possibility that the patients may be selected for the study group or for the controls, and the trial is said to be randomized. A randomized controlled trial makes bias, error in a study which influences the result. These biases are very important to check. Less likely, okay? An additional way of removing bias is blinding. Patients don't know if they are receiving the treatment or the placebo. If, in addition, the researchers do not know who is receiving the treatment, the trial is a double-blind trial. Randomized controlled trials are used to test treatments or preventive measures. For example, when we were with the pandemic times, with the COVID-19, in Argentina, we had a big study, double-blind trial that was developed by German doctors, bringing them the vaccine. And some Argentinians went to the television and yes, I'm into this study, this control, I'm a part of this trial, but I'm not sure if I received the vaccine or the placebo. So that was an important point because nobody knew about it, just the German people who were talking about this study, who were receiving information, and they didn't know which one was with the vaccines. They could realize which one received the vaccines when in hospitals were arriving patients with some complications that were from the vaccine. In another case, control made in Europe, I'm not sure in which country, I think it was in Spain, there was a blind trial because doctors know which one was with the placebo and which one was with the vaccine. And they could notice the difference between the kind of the developing situation with the COVID-19 and pneumonia, comparing the images, the X-rays, the chest X-rays, comparing the ultrasounds, the lung ultrasounds, and comparing, of course, the CT scan of the lungs. And of course, we all know that with these kind of studies, we could support in a short time the effectiveness of the vaccines, independent of the type of the pharmacy it's done. We have the idea that we need the vaccine for going ahead. Moreover, if we have risk factors for getting complications. Well, this is a picture. I think it's funny, but it's true. Well, of course, he still is in clinical trials, but he looks very promising. At this moment, we have objectives with antibiotics. 10 objectives that we are following, we are trying to reach, and we are looking for new ways of medication against the super infection, the super bacteria, the escape one, SKAPE. If you can study them, that's perfect, because the next pandemic situation is not going to be with a specific bug, for example, a specific virus. It could be with this kind of super bacteria that any antibiotic makes the correct effect we expect. So the clinical trials with this medication, it's important. It's important for us to check as a literature and the way we get information. Okay, going ahead. We must consider the variables. So it's important for us to check these conclusions. Agar Can you listen to me? Can you read this?
Yes, teacher. Variables that which is inconstant, which can or does change, as contrasted with a constant. Two, dividing from the type in structure, form, sociology, or behavior.
Physiology. Yeah. That. Form, physiology, or behavior.
Behave.
Yeah. Thank you so much, Agar. So we must consider the variables as the objects of the study that can change, can be different from the study that the researcher is going to define. The variable is the most important part of the study because we define which parts and specifically we are going to see, to check, and then we organize them in order to have the correct idea, the correct result we are looking for. Variables could be age, could be weight, could be sex, male or female, could be activity, could be, I don't know, lifestyle. It depends on the situation you are looking for and studying. And we have again this structure. And let's see this example. If the subjects in a study are all aged 50, then age is a constant in the study because 50, the age is not going to be different from each one. We choose the group with 50 years, 70, lots of numbers between. Another one with 30, another one with 22, another one. So it's not the same data as this first one. We have to get this difference important. The constant variable, the one that is the same for everybody, and that's going to change, and the variable that is going to be between among a range. Okay. A confounding variable is any variable which is associated with both of the disease and the risk factor being studied. For example, smoking in the case of cooks and lung cancer, discussed in Unit 44. You remember, right? How we were talking how cookers were in the possibility of getting with lung cancer because of their jobs. If such variables exist, there is no way for the researcher to know whether the difference in the risk factor or the confounding variable is the one that is truly causing the disease. Of course, we have to consider all the possible variables when we are preparing the research study. Okay, it's not as hard as it looks, but we have to be so focused on the results we are looking for. We have these types of variables: independent, dependent, and controlled. The independent, we choose, for example, the one thing you change limits to only one in an experiment. For example, the liquid used in to water each plant, just the liquid. Independent variable. You don't measure the liquid, you just use it, and then you consider that any liquid could work. The dependent, the change that happens because of the independent variable. Example, the height or health for the plant. It's dependent variable. If I use some Coke, what's going to happen? If I use water, what's going to happen? The dependent variable, I compare this difference with juice from Coke, and then I see the dependent goes against the independent variable, okay? And the controlled, everything you want to remain constant and unchanged. Example, type of plant used, pot size, amount of liquid, soil type, etc. Of course, you have control variables because you are organizing the situation in order to study with specific data what is going to happen. If you use water, you know that the plant is going to grow up. If you use juice or soda, you know the plant is going to die. So you have to consider that in the controlled variable, you can organize the information, you can reach the objective, and then you can get if your hypothesis was right or wrong. That's the importance of this. Just for information. Okay. Hello. Okay. There is no problem. So during our time, I mean, during the medical school, during the residence, while we are developing our job, of course, of showing data with graphical formats, with amounts, with bar charts, line charts, cake charts, that's all. So we have lots of ways of showing and presenting information. Hello, can you listen to me?
Yes, but sound is like recorded.
Hi.
Hi, teacher.
Let's go.
I can hear you very
Yeah,
well.
I swear that
There is trouble with your internet connection.
yes, I'm checking this at this moment. Give me a minute, please, to correct it, like taking a little stop. So until this point, maybe any question? Can you hear me clearly while we were talking with the slides?
No.
Okay, I think we all have the idea. Can you watch my screen? I'm sharing again.
Yes.
Okay, thank you. About the data presentation, we have to consider this activity, yeah, as an important one during our career, no matter the time, but specifically it's useful while we are going to be into the residence, into the medical school, of course, and then we have to know how to express correctly when we show this kind of situations, okay? Fabiola, can you listen to me?
Yes.
Can you read this slide, please?
Okay. Data presentation is defined as the process of using various graphical formats to visually represent the relationship between two or more data sets so that an informed decision can be made based on them.
Thank you so much. So here we have the importance of this, okay? To take an informed decision. We can base on this information and get organized ideas, okay? And we have lots of expressions of ways of talking about it. For example, referring to a table or figure, we have this as an example. We consider the table with the number, the title, of course, and we have our variables and the kind of study. Of course, this Pangerol, Lierol, Lumberol are groups of studying that are performed by researchers all over the world. And when we get into the research study, into the article, we get the information of each group made in the periods they were working, and we compare it just all. And we never must forget the key of the abbreviations and the font, and where is this article, or the year we are using this article. It's because the author, okay? In an article, you can write figure 1 or table 1 shows X. I mean, table 3 shows the summary of original studies reporting risks of disease, So we have the idea, but that's the way we have to express. This is the specific word, show. The figure or the table is showing us specific information. Or we can exchange the expression. X is shown in figure or table. And for example, the comparison between Pangerol, Lierol, and Lombarol is shown in the table 3. And that's all. In a presentation, you can use the same expressions, or you can say, as you can see in table 1, I'm going to correct it. As you can see is the expression you must remember. As you can see, or in the way you see, that kind of expressions are going to be extremely helpful when you go and read it in public, because it's important to use that kind of data. Talking about variables, of course, the objective of variables is to make the comparison, okay? When you refer to a table, you will often need to compare a variable with another one. In that way, X was twice as effective as Y, for example. It's specifically used with comparisons of results, for example. Pangerol says that the study type included control. The study control was a chord, and it was as effective as the cross-sectional that Lombet et al. Used for this chart, for example. X was 3 times as common as Y. Okay, so we have to consider this for comparison. Comparing variables are one of the most important activities we are going to make all of the career. And of course, we are going to get some information, and we have to get the correct interpretation of this. You may need to compare the variables at the same time. We use it with the bar chart. It's the most common way of using it. The number of X in 2000 was double, triple, or 3 times than in 90. So we have the bar chart to compare how was at the beginning and how is today, or how is today, how was in the past, and then we can see the differences, okay? Another way of expression. There was 2-fold increase in the number of X between 1990 and 2000. There was 3-fold increase in the number of. So we don't have to forget these expressions: 2-fold, 3-fold, 4-fold, and ahead, the increase in this compound verb and these expressions, okay? Another way of expression, the number of X increased 2-fold between 1990 and 20, increased twice. The number of X increased 3-fold between 1990 and 2000. It's the same as we were seeing, we were expressing in this way. The number of X doubled between 1990 and 2000. 2-fold and doubled are the same. The number of X tripled between 1990 and 2000. So 3-fold and triplet are the same. So we have to consider this. And that's the way we are going to ask for to relay data, okay, to read that kind of information. Moreover, we have the approximating. The approximating is, Ruth, can you read this slide? Please?
Yes. Approximating. When referring to the data present on slides, numbers are often rounded. For example, 41.3 becomes 41 or even 40. When this is done, it is common to use expression of approximation. Side effects were reported by about, around, approximately, roughly, some 40 patients.
Thank you so much, Ruth. So we have this idea. The approximating is for avoiding this kind of reading. 41.3, of course, it's boring. It's not interesting. It's lose the attention of the people that is listening to us. And we have to use rounded numbers. That's the objective. And the use of rounded numbers is not a mistake during this kind of expression. We tell our listeners that the information, of course, it's expressed in the chart with 41.3, for example, but we can read 41 and that's all. That's a good way to do it. And the verbs that are important for this activity are about, around, approximately, roughly, some. Don't forget, those 5 words are very important in the way of expression in this kind of exposition. The approximating activity is very common in our country, in our career, I mean. With this chart, with this slide, we must understand this. Numbers are frequently presented as fractions or percentage, even when the exact number is given. So we have more ways of expressions. Roughly, 2/3 of patients reported side effects. We don't read the number. We give the idea of this fraction, and then the listener says, okay, 2/3, okay, it's similar. 2/3 could be not exactly number we are talking about, but it's important that the expression is given as the idea that what we are talking about. Or in another way, 55 or some 2/3 of patients reported side effects. You see, 55 or 2/3, these expressions of fractions are important, okay? When you want to emphasize a number, for example, 9.8%, you can say almost 10%, nearly 10%. You are not saying the exact number, not the point one, okay? More than 9%, it's a key, over 9%, it's important, or just under 10%. So we have to consider these ways of expressions, right? And it's important to get the idea because when we use these numbers, we make the exposition more interesting. And our listeners say, okay, that's great. That's a good way of data. And in another way, when you want to make the number seem small, less than 10%, of course, it's less, that's the truth. We don't say the exact number, we have the data, we have the idea, and the listener says, okay, thank you. If you have the opportunity to participate into an international congress, I mean, you can see that these expressions are very common in use and nobody is reading in this way. 9.8%. No, it's not interesting. It loses the tension. So it's important for us to consider these expressions, these specific words, okay? Moreover, we have the line graphs. The line graphs are very common for us and we are used to work with it. And so as a line chart or a line plot is commonly drawn to show information that changes over time. So you can see this is time. You can plot it by using several points linked by straight lines. You see the points, and you see the straight line. It comprises two axes called the axis and the x-axis and the y-axis, the x and the y, okay? So we have this idea. And as I was telling you, it's a very common chart that we use all the time. And of course, we have verbs to describe this. Notice the verbs used to describe changes over a period of time. The cross is going up, rise, increase, or go up. Yeah. Then goes down, fall, drop, decrease, go down. See, you see opposites, right? When we have this broken one, reach a peak. This is the peak. We reached the peak and then we were going up, we reached the peak and then we started falling. It's okay. Remain the same. It's a plain cross and then we have the idea that there's no changes through the time. So notice the difference. Rise sharply, steeply, rapidly, and goes too fast up, or rise steadily, gradually, when it takes its time to go up. With this, we can see it is not a rapidly rise, increasing 9. We have steadily or gradually because it goes through the time, okay? We have the pie charts. It's a very interesting one. It's a type of graph in which a circle is divided into sectors that each represent a portion of the whole. All of the pie, the whole pie is the complete number of the study. And every slice, every piece, every portion is a percentage of the investigation of the data we are studying. Pie charts are an effective way of showing the relationship of parts to a whole. The complete circle or pie represents the whole. As I was telling you, we have the whole, while the parts are represented by segments or slices, we say. For example, in this, we have the favorite type of movie, science fiction, for the 20%, drama, 5%, romance, 30%, comedy, 20%, and action, 25%. Every slide has the size representing the percentage. And the number, of course, is giving us the correct order to understand. Making a list, where is the position of that kind of movie. For example, we have this another kind of expression. We have the number, the percentage into the slice with color, and with the color we express which country we are talking about, the Wealth of Nations. It's sourced by the World Bank. So we have that official data that is shown us by a pie because it's easy to understand, it's colorful, it's nice to see a pie chart. I didn't meet anyone who don't like it. More examples, how we can write down on it. We can write down into the slices what we are talking about, the percentage, and of course the legend. Never forget where is this information from. And we have this reading, understand? So we have the percentage giving us the idea where the position is going to be done. And we have the time spent on smartphones and tablets by category. So smartphones and tablets, we have the division, and we can compare this information because they have the same variables, okay? They have 1, 2, 3, 4, 5, 6. You can see this, 1, 2, 3, 4, 5, and 6. 6 variables for smartphones, 6 variables for tablets are the same, so you can compare the information and then you got the idea. Now, talking about describing trends, the way the verbs exactly we use for this activity, we consider first this. A trend is the general direction in which something is developing or changing over time. How to the time the situation is changed. A projection is a prediction of future change. Trends and projections are usually illustrated using line graphs in which the horizontal axis represents the time. The plain one is the time, and then we have the variables in the x line, in the x axis, and we can go ahead. We have specific ways of expression. We have verbs to describe that we got the idea in last slides. More verbs to describe, we got the idea. We have more, for example, decline, plunge, plummet. We have increase, we have soar, ground, jump, that important ways of expressions, okay? Adverbs to describe how, sharply, quickly, rapidly, steeply, considerably, significantly, substantially, steadily, gradually, moderately. You see the difference of the position of the line, so you can get the correct expression. Slightly, slowly. How to describe this: stay, remain, plus, constant, steady, stable. Stay constant, remain steady, remain stable. So getting these ideas, it's easier for us to get these kind of expressions. And of course, we have the word order. We have to consider the subjects, these verbs, what happened, and the adverb, how it changed. So sales fell slightly, fell sharply, fell significantly, for example. Production rose sharply, rose dramatically. The number of eggs increased sharply, increased steadily, increased dramatically. So we have to consider these combinations, okay? There plus B plus A is the correct way when we start talking about it. There is a, there was a, there has been a, there will be a, the adjective and the noun. There is a slight rise and our variable in sales. There was a gradual fall in the price of X. There has been a dramatic drop in the rate of, and then we continue. There will be a steady decline in the number. There will be a steady drop, there will be a steady fall, and then we consider these grammar keys for writing down and interpreting correctly, okay? Describing trends, the prepositions. You have this, a simple description, for example, it decreased from 10 to 4, from 10 to 4. You see, 10 to 4. Just follow the line. There was a drop of 6 units to 4 and 6, okay? A decrease in the number of 10 between 2010 and 2014, from 2010 to 2014. So you can see how we can use these verbs, these prepositions, in order to express in a correct way or in another way. And again, a simple description. It started at 4 units. It peaked at 10 units. It dropped by 8 units to the lowest point at 2 units. It increased to 6 units. It remains stable between 2010 and 2012. It finished at 6 units in 2012. So you can see, using these prepositions, we described all the picture, all the line through the time, getting the correct point of the every data. And we have this one, the noun, the verb, to consider this situation, okay? The peak, to reach the peak, the plateau, to reach a plateau. The plateau is the remain line. It's like a base in the middle that is constant, that is not going to change. So now, a fluctuation, we have this kind of line. Verb, to fluctuate. It's the tendency says that it's going to fluctuate this period of time. We are watching, or there is a fluctuation in this period of time. The noun, we have a dip. Verb, we can see how it is going to dip. Perfect. Noun, its lowest point, its lowest amount. Verb, to fall is the lowest point, to hit its lowest point. So you can see, right? A peak, you see the peak in the last pictures. To reach a peak is the verb, right? Now the plateau and the verb, to reach a plateau, the steady situation, okay? It's easy, it's just practice and practice and practice and then reading. We have more vocabulary and word orders, the nouns, the infinitive, past tense, and past participle, just for helping, for giving the idea and for checking. For example, the noun rise, we have the infinitive to rise. We don't usually eat in past tense or past participle, that's why it's not here. We have increased in past tense because we always try to use it. And now it uses as an infinitive, so no, it's not correct. A decrease, we could feel it as an example as working. If there is no answer, just an X and that's all. Forgetting the differences, we could practice with this, but that's okay. The fluctuated, the noun is fluctuation, infinitive fluctuate. Again. We also have that the prevalence of HIV in the different countries. HIV rates have fallen in some countries as a result of safer sex. But the overall trend is increased in HIV infections. The steepest increases in HIV infections occurred in the Eastern Europe, Central Asia, and East Asia. But Sub-Saharan Africa continues to be the most affected part of the world. Adult infection rates in Kenya have dropped from a peak of 10% in the late 90s to 7% in 2003. HIV rates in pregnant women in Zimbabwe also fell over the past 2 years. We have the years, we have the countries, and we have the percentages. As I was telling you, we use the percentages as a rounded number, as you could see. And don't forget, never give up. Never give up, never forget that it's not a piece of cake, this kind of work, but we can do it because we are prepared for do it, for interpretation, for reading and practicing. Any question maybe at this point? Hello?
No question.
Okay. Thank you so much. So tomorrow maybe while checking again the slides, you could have questions about it. And tomorrow we can solve them, and we are going to practice with easy exercises just for constructing the correct idea in the way of using this material, okay?
Okay.
Okay, thank you so much. So if there's no questions, I think we can go for studying, for reading, for practicing.
Thank you. Bye-bye.
And it's nice to see you every night.
Bye.
Bye, my dears.
See
Go
you,
on,
see you
go on
tomorrow.
reading. See you tomorrow. Bye, everybody.
Bye.
Bye. Well, we finished 9 o'clock. Yes, that's an objective to finish on time. And well, that's